All right, welcome. So you guys just kind of like face that way. We don't like visuals. We're scared. It's all good. I'm just making fun of you. Welcome to the Indy.net Consortium. Thanks for joining us tonight. Tonight we've got Shiv Kumar talking about coding with intent. I'm a huge fan of that approach to development. Is anyone here from 1150 Academy? You're not sure. It's not like a comedy routine where I'm just kind of pelting with insults. Anyway, so when I taught at 1150, I was into talking about coding with intent, because traditionally what I found, and not to steal any thunder from you, is, and let me know if I can, oftentimes when we learn to code, we're taught to just do stuff. Just start with the code. Just start writing code. That's terrible, because if you don't know what your intents are first, how do you know when you're done? So I'm excited for Shiv's presentation, because I love it. We're recording it, so if you want to share it with your colleagues and such, it'll be on YouTube. We'll put the link out there, and then Shiv, I think you're going to send the slides. Sweet. Special thanks to our sponsors, Theorist for pizza. Woo, pizza! And Jed's Pizza. Yeah, Jed's Pizza. That's spared no expense. Awesome. Did anyone come to the meetup yesterday, the lunch at launch? Yeah, that was pretty cool. Thanks for coming. I hope you enjoyed it. I just did the drawing today, but I haven't notified anyone. So yeah, you're still in the running. Also, before you leave, come and get a ticket so that we can do a drawing for the Code license. So just, and if you have to head out, then you won't be able to win, because we'll just draw a number and be done with it that way. Next month is lightning talks. So anyone here done a lightning talk before? So lightning talks are cool. Basically, we'll have a whiteboard, and you can just sign up for 5 to 10 minutes, where you can talk about any topic that you want. So if you have something that you want to talk about, some tech that you're into, maybe you're playing with Azure DevOps or Xamarin or some artificial intelligence thing. We've had a lot of topics before that were really neat. And so I asked around, and it seemed people wanted those to come back. So we're going to do those quarterly. So once a quarter, we're going to have lightning talks, your opportunity to talk, discuss, etc. You don't have to be an expert in the topic. You can just explain it to everyone, and people will be interested. And we'll record those so you can show it off. Unless you don't want to be recorded, let me know, and then I'll just stop the recording. Yay. Other than that, if you go onto our meetup site, you'll see that we've got the next 6 months, or 5 months now, 6 months, 5 months of sessions already planned out. So if you want to know what's coming up, we got a whole thing on Azure DevOps. We've got the lightning talks. There's others I don't know them off the top of my head. We might even be out a little bit beyond 6 months. So we try to keep that hopper full. If there's something you want to talk about, just let us know, and be glad to have you. If you know someone that you'd like to push in front of us so that they talk, yay. It's always good when people present. Always enjoy that. So let me think, is there anything else I need to cover? Oh, and then other sponsors, Launch Fishers, they're giving us the theater for free all year. 1150 Academy, who gave us space over there, and then we outgrew it, but they send their graduates and their students here, and they've been a great partner, and continue to be. And of course, Code. So anyone who knows me knows I love Code, and it basically does for debugging what ReSharper does, and I don't mean makes it slower, it makes it better. Where you have like a tabbed exception window, you can actually scroll through your link queries and see how each iteration went. You can see a whole bunch. Does anyone else here have Code?
I've used it in the past.
Have you used it?
Yeah.
You like it?
Yeah, it's pretty sweet.
See? Look at that. That's 200%. So 2 out of 2 experts agree. Code is phenomenal. It's like everyone should have it. Or win a license, and you could also be an expert. Anyway, without further ado, Thank you, Shiv. Come on up. He's going to talk about coding with intent, and like I said, all the details will be online. So give it up for Shiv. Thank you.
This is an IoT, by the way. Sure. No, not able. I thought I'd switch the tone on you guys if this was all of interest. My name is Shiv Kumar. I'm a senior solutions architect at AIS. We are looking to hire people, seniors and architects. So Matt's here and Lisa's there. Lisa's sitting over here. If you are interested, please contact us. My blog, my YouTube site, and Twitter. So my YouTube site is just youtube.com/matws. So programming with intent is a big topic. It's not a small topic. It essentially encompasses pretty much everything from coding to system design, like everything. But today's talk is just method design, not class design or programming with exceptions. But they're all kind of key parts to the first part of programming with intent. I normally do this as a 3-week session. This is like this is down to 1 hour session. But it's going to be challenging for a lot of you, especially the experienced people. You're probably doing things wrong for all your life. I'm going to tell you that you're doing it wrong. But I'm going to let you read this philosophy of mine. It's 2 slides. Essentially, everything you're going to see here is coming out of experiences where I have tried everything, every possible option that I know of, compared and contrasted them. And what I was saying, I don't just do what I've been told. I'm always trying things, and I'll see for myself what I like or don't like. It's not about a preference that I have on my own, but I like things that work and don't work. And I make my choices based on the cons, not on the pros. Meaning, if I'm willing to live with the con, nothing is only pros. There's pros and cons, and the idea is, are you willing to live with the cons you're getting for the thing you choose? Right? The pros are pros, great. But I want to live with the cons. And so it's all about trying to figure out what are the trade-offs you're willing to live with and what trade-offs you're not willing to live with. Right, so a lot of stuff you're going to see here today is going to be contrary to what you've been hearing and reading and doing for most of your lives, at least programming wise. So why method design? Because I believe if you can design a method well, you can design a class well, you can design a system well, an API well. If you don't design a method well, then all bets are off. Nothing's going to work. And method design is key. It sounds simple, but it's actually not as simple as one would think, because there's lots of nuances and details to it. So I tell people, you want to tell me a story, right? When you write your code, you want to tell me what it is you're doing by way of code. You're telling me a story, but you don't want me to think, and you don't want me to wonder. And if you've done code reviews, if you look at code of your own code from the past, you're going to say, okay, right, I'm not sure what I was thinking then, right? I don't want to be in that situation when I'm reading somebody else's code. So don't make me think, and don't make me wonder. So leave no place for wiggle room. Your code has to be exactly how it's supposed to be, and there are no 2 ways about what your intent was supposed to be, or intent was at the time writing the code. It's just more about, I call it programming with intent. So everything you do is just showing me your intent. And so you don't want one of those WTF moments, right? What we joke about the number of WTS people, WTS per minute, right? Somebody sees your code. So I don't want to be the receiving end of this. This is just sort of the driver for me. Like, don't want to hear that. So naming, for whatever reason, naming is the hardest thing that one does in programming. Whether it's naming a class, naming a method, naming an argument, local variable. Because the name conveys pretty much like 80% of the story, right? if you didn't name something correctly, nobody has a clue as to what you really intended to do with this thing, the variable or method or the class name. And because of the fact that it's difficult to determine what the name of the class should be or the method should be, if you didn't pick the right name, then the next person is not going to understand exactly what your intention was. And so what you want to keep in mind is you might give something a name now, but maybe 2 weeks later, maybe 2 months later, you actually have a better understanding of what this method is doing now, what the class is supposed to be doing now. So go back and rename. Don't be shy to rename classes, methods, arguments, stuff like that. Because as you're building out the system, your own understanding of what it is you're doing is becoming better. Right? So you want to rename those things. And of course, today's ID is control dot, or whatever your shortcut is, does that magically. So you don't have to worry about renaming things. So, what's wrong with that? Let's do it line by line. So what's wrong with the first line?
Oh, you don't realize that it's first and last name. It's just name.
Exactly. So if you have the time to put in a blooming comment,
And it's
just use the right variable name, right? I mean, so comments are not allowed in my world. You cannot comment your code, right? This is one of those things because if you can't tell me your story by the code you're writing, then you're just missing the point. So comments, of course, the moment you see comment, that means something's already gone missing. I just put that in a codified in the language of your choice. So I'm guessing the same as the port number, right? If it's the RabbitMQ port, they just say call it RabbitMQ port. Why call it port and it says RabbitMQ port? Just call it RabbitMQ port, right? Then these others, the next line, the return, resolve val, wet val. These are of course, I'm sure we all. By the way, none of this I was not born with this knowledge. This is all through experience. This is about 15, 20 years of making all these mistakes. I have no problem with telling you that I did exactly all these things, at some point. I've just been introspecting and trying to clean up. So this is the culmination of 22 years of experience. It's obviously something you do when you write the return of a method, right? So what's wrong with that? What's wrong with red val or result? The problem is that before you return it, it is something in this method. Right? It is something. Call it that something in this method. Because in this method, it's not return val, it's whatever it is. If you're returning, let's say, the salary, then call it salary. It may be something you're returning, but it's not red val in this method. It's the salary of the person, right? It's whatever the thing is. So call it what it is in this method. Don't think about the fact that it's being returned at 2 lines later. Call it the thing so that you understand what it is you're returning, because that may not be clear, by looking at the code. And then count. Yeah, I think these are all cop-outs, so think of better words than variable names and temp and count. Count of what? Okay, this is probably too small for guys in the back, right? Okay, so it's a lot of gobbledygook, but the name of this method says process vehicles. There's a bunch of processing going on. And the problem is, okay, you're processing vehicles, I understand that, but what exactly is the process? Why are you being so vague about the whole thing? It's a little more intentful. Show me your intent. Tell me exactly what you're doing so I don't have to look at the method to figure it out, right? That's the whole point of a name of a method is name the method in such a way that I don't need to go in to see what it is you're doing. The name of the method, the signature of the method is what are the input arguments, return type, should tell me exactly what's happening without me having to know how it's being done. Because otherwise I have to go in there, figure it all out, and then say, oh yeah, so you're processing what? Coverage premiums. Right? I mean, I know that. But you won't know that by the method process vehicle. What vehicle and what are you processing exactly? Now there's a lot of things that, when I say naming something, right? You name something. That doesn't mean start naming the loop variable I to something else, because that's idiomatic C# or pretty much idiomatic whatever language I've worked in. So you don't say for, I don't know, vehicle count equal to 0 to whatever, keep it I, because you want to remain idiomatic. You don't want to confuse people now going kind of obtuse from the idiosyncrasies of the language. Right? So the loop variable, for example, is a good idea of don't change it just because I said name everything correctly. Method name should use the vocabulary of the domain of the business. And the business could be a game. If you're writing a game, it's the business of the system you're building. Names of methods should always be business-centric or domain-centric. So you're not trying to make things technical, even though you might be doing work that's technical. What is it for the business? What is that thing doing for the business? Let's be named at the business level. So pretty much from the controller or whatever your front end is, all the way to the store product, the names are domain-specific names. And for the most part, at least in my systems, if the controller is called, calculate premium, there's a store proc, 20 feet away from here that's called calculate premiums. It's just the same name across the board. So you don't want to start changing names as it goes through the system. Who's had that situation? It's called do A here, and by the time you go to the next class, it says do C. And by the time you get to the end of it, the store proc's called Z, and you haven't a clue that they're all connected. You can't kind of draw the line without following the code or debugging to figure out how did A become B, become C, become D, even though they're all doing the same sort of function, right? So if I have a controller on this end that says, or somebody says, hey, I call this endpoint and it gave me, issue as what's the endpoint? They say, well, it says, calculate premiums. I can look at my store part called calculate premiums, just blindly. I'm not trying to decipher the system just to figure out where exactly is, which store part is being called. So for the most part, the names follow through, but the names are business-centric. And the same goes for the formal arguments of a method. Keep them business-centric. Don't give them technical sort of sounding names. Give them business sounding names. So it means something to the business. Everyone understand the point? Business-centric domains and names. In C#, if I don't provide the access modifier to a method, what is it? Private, public, internal?
It's private.
Private? For methods. Of course there is. Yes, methods can be internal also. Yes. So, programming intent actually says, show me your intent. So don't assume I know it's private. Like, I don't know, did you forget? Did you not put it there? Did you actually mean it to be private? I don't know. So show me your intent. So even though you may know it's private, I'm saying mark it as private. Don't assume that the next person knows that you forgot or didn't forget or intended or didn't intend. Show me your intent. Make it private. Don't assume everyone else understood that because you didn't mark it with the access modifier, it's private. Some people might think it's public, I don't know. So show me your intent, right? Be very intentful in the way you write your code. So I have these phrases like we don't expose our privates. A lot of these little phrases will also help you remember the rule. And so the idea is, if methods start their lives as private, meaning you don't know, even if you know for a fact that, well, you sort of have a sense that maybe this method should be public, it doesn't matter. If you don't know for sure, it's private. Because you can always make it public, later. You can make it protected, later on. But it starts life as private. So even when I define a class, you see, classes start their lives as internal seal. I don't say a new or public class. I say public. I say internal seal class. Because classes start their lives as internal seal. Methods start their lives as private. Because you have the opportunity to then later on change to make it more visible. So protected and public are more visible than private. You can't go backwards. If you go backwards, you're going to break something somewhere. Right? So you don't want to take that chance. So start method lives as private, and then you can always modify them later on. And explicitly mark the access modifier as private. Don't assume that everyone knows that methods are private by default. This is a guideline from the Framework Design Guidelines book. Anyone know the book? Framework Design Guidelines? Yeah. So it's a nice book in the sense that it was written after about 10 years of .NET experience by the C# and .NET team. 10 years of their experience, they decided to come up with guidelines, the things that they learned lessons from over 10 years. The do's and the don'ts, the good and the bad. I don't agree with a lot of the guidelines. And the format of the book is such that there's a guideline, and then they ask 10 people from Microsoft what they think, and nobody quite agrees with the guideline. So, but at least you understand the reasoning behind it. So it's a pretty cool way to get a sense of what each person's insight into their own style of thinking is. So it's not unusual if I don't agree with some of the guidelines, but I do agree with this one. And because there's a bit of a security risk for exposing public virtual methods. So their guideline is, instead of doing that, you do this. And for the people at the back, hopefully I can explain it. There's a method here that is called retrieve client. And let's say I'm writing this method, I say, yeah, this should be virtual. In my head, I'm thinking I'm designing this class, and this method should be virtual. But it also needs to be public so somebody can access it from the outside. The guideline says don't make that method virtual, so leave it public, leave it as not virtual, and then have another method with the same name, so it's still called retrieve client, but it's got a suffix of core. And you're just calling the core method from the public method. And the core method itself can be virtual, protected abstract, or protected virtual, depending on what you do. Rather than making the public method itself virtual directly. Of course, if you follow this convention, then anytime you see the method core, you know that it's definitely virtual, and somebody else is calling it, some public method in the class is calling it, because that's the convention. What method? The method that the first part of the method names is the same, just the core is the suffix, so you can always find the method it's calling. And if you are overriding methods in a class, then as soon as you override the method seal it. What does seal mean in C#? Sorry? Can't inherit. Everyone agree with that? What else?
Well, can't be overridden.
Yeah, it's kind of like what you were saying.
Yeah. I actually have a question about your previous slide.
Sure, by the way, please stop me. If you disagree, just stop me.
Oh, definitely.
I'd love to argue with you.
Oh, then we're going to be great friends.
Well, that depends. Are you agreeing with me or disagreeing with me?
No, I'm disagreeing in all cases. So why are you saying, or why do you agree with this, that you can't make a method and an API to be virtual? So let me qualify that. There's writing a framework that you're going to give to public people could have different rules, what we'll call these coding standards, right? Then an application that you're writing and it's internal, right? When you need to have these.
The same rules apply, whether you're writing a framework or an application.
Okay, so why would you not want to use the virtual?
The public method
capabilities of-
virtual?
What?
Why wouldn't I want the public method to be virtual?
Yeah,
Because as I said, it's a security risk.
explain.
Well, it's complicated.
Okay, you still have to explain it.
Yeah. So what happens is, if a method is virtual and public, then I can hack into that method and change its implementation. That doesn't mean anyone can just go ahead and do it.
You're talking about with reflection. Right?
Yes. So it can be hacked. If it's not virtual, I can't hack it. I can't change its behavior. I'm living with whatever its implementation is. But if it's virtual, I can actually change its behavior. You wouldn't know it's been changed.
Right,
and
you're
therefore it can
using
be
the
hacked.
framework, using .NET's capabilities of doing that.
Yeah, I mean, if you know a bit of IL, you can reverse engineer it and change the IL and push it back.
Oh,
and
yeah,
get done.
you don't even need IL, yeah.
Oh yeah, there's 10 ways to do it. But so that's the security risk, and so they're saying if you don't want that security risk, then don't make these public methods virtual. Therefore, they can't be hacked.
Okay.
Which is the reason I'm agreeing with it. So yes, it adds a little more work, to add another method by the same name and a core suffix and all that.
Okay,
but
you just add another method and then you get rid of it. I understand.
Yeah.
All right, thanks.
if you're overriding methods, then you want to seal it. So you've got a class and it allows you to have if it has a virtual method, you can override in a descendant class, seal that method. Right? Don't think, what if, maybe, don't know, just in case. Those words don't exist. You only know now, you can see so far. And so far, you don't need to override, seal it. If you ever need to unseal it in the future, of course you can do that. But you can't ever go back again. You can't have a method that was not sealed and then seal and potentially break something. So best is to be kind of seal it. Now, there's a bit of a nuance in C#. You can seal a class and you can seal methods, right? In C# you can seal methods and you can seal classes. The .NET team does not give you a guidance as to what should you prefer. Should I seal the class rather than seal every method and leave the class unsealed? So I seal the class and seal all methods. And what are the combinations of all those things? So my recommendation is seal the class if you can seal the class. Meaning, if all methods need to be sealed, then seal the class. Don't bother sealing every method individually, because if you ever need to unseal it, you just flip the switch and the entire class is not sealed. Right? But there are cases where the class itself doesn't need to be sealed, but some methods may need to be sealed, then seal it at the method level, of course. But if all methods are to be sealed, seal at the class level rather than sealing at the method level. Anyone know the nuance in C# with internal? In .NET in C#?
Yeah, you did.
Yeah, what? Oh, if I said protected internal.
That means the only types in that assembly can see it.
Protected internal?
Yeah.
I mean, it's virtual, yes. It is virtual, yes. But so it's obvious after you've been doing C# for long enough, but in my mind, protected internal should have been, and .NET actually supports it, but C# doesn't, it's only protected for classes that are in this assembly, but internal actually is making it publicly available to all other classes outside the assembly. So it's breaking the notion of protected. The default implementation, not default, the way C# behaves today, protected internal means it's protected for classes in the assembly, but it's publicly available to all of the things outside of that assembly, right? Which is, I think, in my mind, contrary to how I would think about it. I would have preferred it to be, so it's protected or internal, instead of protected and internal. Now, .NET supports both, but C# implementation only does the protected or internal. So it's protected here, but otherwise it's internal.
You're saying if you make it protected internal, then you can see it outside of the assembly because it's internal?
They are protected.
Oh, because, okay, you said internal in that last. Okay.
So yeah, so internal is internal, meaning it's within the
Right.
assembly, but it's also visible to classes, its descendants outside the assembly.
Yeah.
I would have preferred to have that control, like I would say protected internal, that meant only classes descendants of that are in this assembly could use the protected method, which is, I think, a little more useful than, I mean, what the heck is it's already protected, so I'm not sure what. But it's already internal, so I'm not sure what the.
So the internal doesn't make sense.
Yeah, exactly.
At that point,
Yeah, exactly.
Does it just ignore the internal keyword?
Sorry?
Does it just ignore the internal keyword at that point? You make it protected?
I mean, net is ignored, right? Because only classes no matter where they are can see it. So I'm not sure why they implemented that way, because in .NET you have the option to do both. Sorry, either or.
And this is strange.
Okay, as we go through these slides, it's just going to get more and more intense. If you feel like, a bit of unrest, because stuff I'm saying is going against your norm, make sure you ask me questions. So methods should be autonomous. Autonomous, for me, is a method should be given every piece of information it needs to operate on by its method signature, by its arguments. The method should not be operating on some magic invisible things that are part of the state of the class or something else. They're autonomous, so they are self-standing, therefore they should be given every piece of information they require. So it's clear when I look at the method signature and the method name tells me what it's doing, and I look at the signature and say, oh, okay, so you need blah, blah, blah to do blah. And I don't have to look into the method to figure that out. I don't want, it's very difficult to reason about your code when there's stuff happening magically behind the scenes that you can't see. Some people, and me included, you say, I'm going to new up a class, I'm going to set 2 properties, and then I'm going to call a method. Who's done that? New up a class, set a few properties, call a method. The method is operating on those 2 properties. But you don't know that until something blows up first. Okay, I should set these 2 properties before I can call the method.
So I'm reading the C# documentation, and it says protected internal. That's what we were talking about, right?
Yes.
Keyword combination is a member access modifier. Protected internal member is accessible from the current assembly or from types that are derived from the containing class.
Yeah.
So, but other assemblies can't see it unless they're deriving from that.
Yeah, that's what I'm saying. So protected is protected.
Yeah, you won't even be able to see it.
If you're not an internal class though, the question is what happens if you're protected internal?
Yeah, you can't be seen from other assemblies.
Right, so net internal has no meaning. Because, protected already means protected, only descendants can see it. So what's the point of internal?
But if you do, I hear you, but if you do a protected internal,
then you try accessing that method from something that's not in that assembly,
You won't
that
see it.
protected internal will just simply not, it won't compile, it won't be there.
Well, to access protected, you have to be a descendant. To access
Yeah, but
protected,
if you're outside the assembly, it's a protected class, but then you have a protected internal method. Would that even compile?
yeah, you can
Okay,
see
so
it.
then, when you try accessing from outside that assembly in that derived class,
Yeah,
is that function actually available?
yeah,
No.
it is. So that's only, the internal has no meaning.
Line has no, yeah.
Whereas
I would think
protected
that-
and internal would actually have useful sort of purpose if, one would think of it.
Seems like the way it should work. It just simply should be, it won't be accessible
Yeah.
outside of that assembly, but you can still derive. from
Yeah,
it.
so, if I'm setting up a library and I want to give you access to my API or define your own descendants from my classes, I still have little extra capability internal to my assembly that I don't need to expose to the outside. That would have been a much better way of doing, so it would be protected and internal rather than protected or
Right.
internal.
Essentially, you're saying, don't do that, just make it internal, and then you're
Or
done.
protected,
Or protected.
basically.
Right, agreed. All right.
Okay, so back to Thomas, everyone understand our Thomas method? Everyone agree? If you don't agree, let me know. Or if you don't understand, let me know so I can explain it, but I agree. You agree? Just take a count of, show of hand, how many people agree? But there's a key nuance now. The next part that says method should be pure. Pure functional, anyone understand or know of functional programming languages? F#, Scala. So functional programming languages have this notion of pure methods, or pure functions. Their understanding of pure functions is slightly different from what I'm saying here, because pure functions cannot modify state in functional languages. They don't alter state, they don't alter the world. Writing out to the console is changing state. Writing out to a database is changing state. Writing a file, sending up an email, whatever else you do is changing state. In functional programming language, that all is not allowed in pure functions. Not sure what exactly you do with pure functions or in functional programming languages, because if you can't change state, then you're doing this. So, I support both in my programming intent. You're designing methods that are either autonomous or pure. But it's one or the other. I'll explain when and how these things might occur. And slightly looser than the functional understanding of pure, as I'll explain. So this is typically how my systems are designed. There's some class that depends on some other classes, depends on some other classes. And the leaf nodes of my systems are making the state changes. They're writing out to the database, they're sending off an email, publishing a message in a broker. There's the leaf nodes. Which means all the classes on in green are pure, meaning the methods are pure. They're not actually themselves modifying state. This is the loose part of in functional programming. That would not be considered pure. The entire chain is not pure, it's not pure. In my world, those are pure, these are autonomous. These methods are autonomous, the blue, the data access, the email service, the file system access, those are autonomous methods, but they're not pure. They are modifying state. Whereas the other classes inside of the system are pure. And the methods are pure. Make sense?
No.
No?
Go back. Go back a slide.
Go back a slide?
Yeah. So what I'm seeing here is, let's say I've got a WPF application, I have a view model. Okay? Do you know what that is?
Yeah.
Okay. So you've got methods in your view model, like commands, that are going to modify, it's going to take a command, or you're going to have methods that are going to affect the state, other properties within the class.
UI.
Well,
the UI.
we don't have to talk about UI. We got a view model, right? And it's got methods, it's got properties. When things change, that could cause something else to mutate the state. So that method is actually working on a module level property. According to this, I can't do that. Or did I misunderstand it?
No, that's correct. So everything I'm saying here does not necessarily apply to UI things. It applies to everything but UI. So anything that's connected to UI is off the charts or off this whole thing. It's not about the UI.
Right.
It's mainly about the rest of the system that you build behind the UI. Because UI has its nuances and you can't modify, you can't alter.
Right.
all
Yeah.
those things. Yeah. So it's not applicable to UIs, but it's applicable to everything
Right. So
else.
so this is everything out past the UI
Past the
layer,
UI.
service layer, business objects.
All of that. Everything.
Yeah.
Yes.
Okay.
It
Now
so
that-
it so happens when I say I'm building a system, for me the system is not the UI. This is everything else but the UI. The UI is in my world, I'm not saying it's not important, I'm saying it's a nuance.
Yeah.
Right? I could build any kind of UI in front of it, but my system doesn't change. So I'm focused mainly on the stuff that's behind the UI.
Okay.
The UI is the most important part in terms of what the user is seeing is the UI. So I'm not trying to underplay the UI, but everything is applicable more to the UI than this, sorry, to the stuff behind the UI than it is to the actual UI itself. And to the extent possible within the UI, if you can follow some of the stuff, even
Absolutely.
though, it will make
Yes.
sense.
Yeah.
And the reason this is, I don't know why this is, so why I'm saying you should do this. No? Turns out that you can't reason about your code if just stuff is just happening wildly. You know, if you're living in the Wild West, there's no way you can look at things and say, okay, I know what this thing's doing. It's just very difficult. So if the methods are autonomous, meaning they're operating purely on the signature method arguments that are given to it, it's very easy to reason about what this method could possibly be doing with the information you just gave it.
I have a question going, and you don't have to change the slide, but you were talking about how in a method, it should get everything it needs in order to do its job, which I agree. But with a class, sometimes, especially in version control, certain services are injected into the class
Right.
automatically, and you kind of assume in the method that they'll have access to that, and you may not need to be able, you may not be able to push those in, right?
Of course, and you probably don't want
It's
to
a
because,
black box,
yeah.
and you shouldn't control that, right?
Right. So I was hoping somebody would bring
Is
DI
that
into
an
this
exception
into the
to the rule?
conversation. No, in fact, I don't believe in DI. I'm not a DI proponent. No, but so here's the thing.
I disagree with that.
Strongly.
No, but everything I solved here.
Even without DI,
Yeah.
you do a class, if you have
It could have dependencies. It could have dependencies.
Okay.
So
Is that an exception, those dependencies that are part
yes,
of?
so in my world, there are classes that have behavior. I mean, these are things, the classes that do things, right? And there are DTOs. They don't mix. A DTO or a value object will have no methods on it. Like it just is like a container for data. You shuttle it around. That's it. And behavior classes have no state. So they don't have properties. They don't have state at all. So now it becomes a lot easier to work the magic because you're saying here's a class that does things but has no state of its own. It may have dependencies, but those dependencies don't have no state either, and on and on. And so therefore, the entire system is stateless. Therefore, it's okay. You're still autonomous. You're using a class to do other work, right? You need two or more classes to do the work you're supposed to be doing, but you're not maintaining state somewhere. You're not modifying state to kind of do the magic.
Like you wouldn't be modifying properties before you make the call.
Yeah, or within the method, I'm not modifying a property because
But
I'm
just call
stateless.
the method, everything should already be set up for you.
Yes.
That should be-
And simply while the method is operating, it's not changing state of this class, but this
Right.
class has no state.
Okay, so that even though you don't like the dependency side of it, it's okay?
Yeah, if you have dependent classes, yeah.
Okay.
If a class A depends on B, C, and D, yeah, I mean, that's life, right? I mean, you can't get around that. I'm only against the injection part. I don't like to inject my dependencies, but I have dependencies. But
You don't?
behavior, sorry?
You don't inject your dependencies? You knew them up?
No, I don't. I just don't inject them.
No, but how do you create them?
Magic. That's a whole other conversation.
That's it.
That's a whole other conversation.
What? The magic keyword is in. Look up factory magic.
Just a short description for those who are curious. These are long conversations. Some of it, philosophical. For me, an object is a black box. I don't want to know how it works. Like it's like if I went up to my car and I was going to put the key in the door to open it, because hey, hang on, Shiv, like where are my tires? Where's the engine? Where's that? Oh my God, I just want to fucking drive it. So that's where I come from. A black box is a black box. I don't want to know how it works. I don't want to know its dependencies. Otherwise, it's useless to me. It's like somebody comes on my team and says, Shiv, can you help me with that? This, that, and the other. Heck, if I got to do all that, I just do it myself. I mean, seriously, if I got to tell you everything you need, I can just do it myself. I don't need you to use all the stuff I need to give you to do the work. So, sort of on the kind of side of being overly strict. But if it's not a black box and it's becoming like a gray box and a white box, it's sort of useless. So as a result of which, I think dependency injection is test-induced damage. The only reason you're injecting this stuff is because you want to test it. And I don't alter my designs for testability. If you can justify the injection, dependency injection, for anything else besides testing, I'm on board with you.
Oh, I'm 100%.
But if you're breaking the design, if you're damaging the design in order to test, I call that test-induced damage. And that's not acceptable. That's not to say I don't test, that's not to say I can't do all the testing that people who use dependency injection can test. I do all of that, except I don't use dependency injection. I don't damage the design. Big topic. And we already booked for 6 months, so probably hear me 6 months later.
You know, you get a lightning talk.
Yeah, right. It's like some of these guys, with them for 3 weeks talking about this stuff. But it's interesting stuff, but as you can tell, I've given this talk and it started these discussions. I was in North Carolina, I went to, talk started at 12. 5 o'clock was like the pizza and all that, 5:30 the talk started. I was in North Carolina till 3 in the morning on this topic. And so sleeping the night and driving back to Virginia the next morning, I just drove back from the parking lot. So they can be pretty involved. Methods should be given the bare minimum information. So this is the need to know basis. You want to remember the idea is the need to know basis. And the idea is that you don't want to give methods any more information than they need. Let's say you have a DTO that has, or a value object that has, 15 properties to it. And this method needs, 5 of those properties. The simple way is saying, I already got the DTO, just give the thing, to the DTO, to this other method. And I'm saying, no, don't do that. They need to be given the bare minimum information, nothing more. The metaphor I use is if I went to a store to buy something and I bought this TV and the guy says, it's $1,500, and I take out my wallet and give it to him. Would you do that?
Probably not like a wallet.
So I just not to give you a wallet, right? I just to give him exactly what he asked for. Don't give him the whole wallet. Same idea. When you're calling another method, be very specific as to exactly what that method needs. And whoever's designing the method, if it's not you, have a discussion, make sure you're giving them just the information they require, nothing more. The moment you give something more, you have no idea what that person or that method is doing with that information, and then not all bets are off. Suddenly you can't reason about your system. You're saying, man, this guy's trying to process vehicles or process coverages. What the heck is he doing with the customer name? I don't understand. Like, what could he possibly be doing with this information? I don't know. And then tomorrow he ends up using it for something else because he's got the information. And now suddenly your system starts to do all kinds of weird, gymnastics that you never imagined it would do.
And one thing to add to that is whenever you're working on your functions, and though you don't need the parameter anymore, get rid of it.
Yes. Yeah, so that's constant cleanup. Right? You can't leave the code you wrote, 2 weeks ago or 2 years ago, whatever, alone. You got to keep looking at the stuff and keep cleaning it up. Otherwise, the code starts to rot, and then it's just a nightmare trying to maintain. But this and the previous one, the autonomous methods and the pure methods, are a big part of method design because these two things make your system just a whole part easier to maintain and reasonable. I can literally understand systems by looking at the methods and signatures without going into implementations and kind of looking at the detail of that. I don't want to know how, I just want to know what. When I'm discovering a system, I actually don't want to know how you're doing something. I just want to know what the heck are you doing. And the method names and the call chain will explain to me exactly what it is you're doing without understanding the how of it right off the bat. Unless I'm sitting and modifying the code, I don't need to know the how part. So this goes a long way towards making your code cleaner, maintainable. Just deviate from the slide a bit. We've heard of extensibility, reusability, maintainability. Have you heard these 3 things? Let's sort of all this club together. Yes? No? Yeah. No?
I heard two of the
Yes.
things that you said.
Sorry?
I heard 2 of the things.
Okay, so extensibility, reusability, maintainability. You can't watch that now. I'm talking. I'm giving live. It's no on video on
I'm not
YouTube.
even live streaming it, so I don't know what it is.
Okay, so if you were to order this in order of priority or precedence, which one would come first? Between reusability, extensibility, maintainability.
Maintainability.
First?
Absolutely.
Who else agrees with maintainability being first? What about reuse and extensibility?
Extensibility and what?
Reuse, extensibility, maintainability.
Maintainability.
Maintainability is big, but I would think reuse would be the
Reuse
first.
first? Okay, who says reuse first? Reuse, all object programmers, please put your hands up.
I already said it, so.
Yeah. So the trick, this is a trick question for me at least, when I ask this question. I don't give a shit about the other two. Maintainability is it. I really don't care about reuse and I don't care about extensibility.
That's right.
Maintainability is it.
Yeah.
Is it. And the reason is because it's the reusability and the extensibility that basically sends us down this rabbit hole. You know what? Man, this method could be used by this other thing, like, I don't know, I'm imagining all kinds of, nonsense, 6 months down the line, I don't even know enough of, right? I'm imagining these things, and I'm starting to make this method do all kinds of things it was not supposed to be doing today. I don't need it today, but I'm imagining the extensibility part and the reuse part. And now I got all kinds of, fluff in my code that is never going to be used, but I think I'm going to get it right, 6 months down the line, we're going to hit this nail on the head, right? And we don't hit the nail on the head. Now there's this crap over here, and there's 10 other methods, all got all this imagination that we have. Pretty real programming. Very rarely have I hit the nail on the head. I can't see past this, my nose. So the trick is, or the aim is, don't imagine the what ifs, the maybes, just in cases. Don't do that. Write code for what you know now, today, not tomorrow. Now, I mean literally not tomorrow. You might know there's something coming down in the next sprint. Doesn't matter. What do you know now? Write the code for what you know now. Don't worry about, listen, if you design the system correctly, it is extensible without even trying. You can make it change direction in a heartbeat. But it has to be clean and just enough so you can change direction to something else if you need it. If you've already built a system like that, instead of here, what direction are you going to change? I mean, it's a mass of just, what they call big ball of mud. And now it's got no shape, you can't go in any direction. It's sort of just going everywhere because you're imagining to go in all kinds of directions. It's very difficult to maintain. So, maintainability is number one and the only thing you're interested in. If you start focusing on reuse and extensibility, you're going to be in the mess that we're in. I mean, how many people have said that their systems are maintainable by a whole other team? Really? Nobody's saying. So, guess what, right? Huh?
My software is.
Yeah, I'm sure we all think that. But nobody raised their hand, so I'm a bit surprised that nobody's in mind this. Okay, so we're all being honest, and I think that it was a huge eye-opener for me. It took me a few years to recognize this. Initially I thought I was just becoming dumber as I got older. Who's had that feeling? Me or the older people that think they're getting dumber as they got older? I'll tell you the trick to this. I'll tell you I discovered the real thing. I've maintained all the code I've written from the time I started programming till date. Any code that was not under whatever, company, what do you call it, Indy and stuff like that. And go back to this code and think, I was really smart those days, man. This code is like incredibly beautiful, but yet I can't read it. I don't understand what the heck it's doing. Right? So obviously I'm thinking, how smart those days. I can't understand a word of what it's doing now, It takes me like something an hour to figure this out. Maybe to make it in a way that it can run. I can debug it, and oh yeah, of course. I was getting very depressed over the years, thinking like this is just not fair. I mean, I knew all this stuff and I don't understand anymore. Until I realized that code that I wrote that was like 4 lines of code took me like 2 weeks to get to 4 lines. Right? And I gave myself a pat on the back. And wow, that's like too good. Who's done that? Who's given themselves a pat on the back saying this is like fantastic code? I mean, nobody in my team is going to be able to figure this out, right? I'm so smart. Until I fooled myself, right? When I went back to look at it, I can't figure it out. And I realized that when I'm going back to this code, I just have 5 seconds, 5 minutes to figure this out. And I can't figure it out, which means I'm being too clever. I started to unwind all of that. So I went from wanting to make this reusable code that's so succinct and clever to I don't want clever people on my team. I don't want to be clever because I can't read my own code. And if I can't read my own code, who the heck is going to maintain the system I just built? Right? So maintainability is number one, and the only thing to worry about. When did I get to this slide? So There are two kinds of methods. Methods that are actions or commands, they do something. But they do and return nothing. Okay? Void returning methods. They come back with nothing, but they only do. They're actions or commands that do but return nothing, void return. And then there are query methods that retrieve but do nothing. They don't modify any data, they're only retrieving. Right? If a query method can't return what you ask for, it does not return. How many people can say that they're writing code like this? Method does something, returns nothing. You do?
Yeah, absolutely.
Does something, returns nothing. So you insert some record. Do you want to know that the record insertion went okay or not? Would you not return, I don't know, result code, bool?
Well, it depends. I mean,
It depends.
If I do something that I need to know true or false is one thing, but the other one is return the updated.
No, but if you do something, why do you need to know true or false? You're saying you do something and that comes back with a true or false, that's almost like saying you want to know if it did it or not, didn't do it.
Yeah, no, I'm talking about,
The query?
if it's an action that does something that needs a result, the data should be coming back to me, whether.
The anomalous case in that is like, say you're inserting a customer, you want to get the new customer's ID back.
Yeah, well, or a result that it's succeeded, or the.
No.
Or
So
the-
if you're returning a result to say success or failure, not allowed. Not allowed.
Not what?
Not allowed. Can't do that. Void returning. Against the rules. Against the rules.
So how do you get the ID?
Yeah, so that's the anomaly. That's the anomaly for when you say create customer or create order and you want the order ID back or the customer ID back. That's the anomaly. But
Let's say you need to scrub user data. You're saying you should throw an exception then? If it's gonna fail, how do you indicate?
okay, so but hold that thought. I'll come to that.
All right, so I have another use case. It has to deal with concurrency. So let's say I have a customer, a record, and I update it to SQL Server, right? I need the timestamp back. I have to have that back so that I can update my object guy, so that the next time he updates, he's passing the
newer
correct timestamp.
timestamp.
Yeah.
So there could be anomalies to it. The basic idea is you're
Alright,
not
so-
trying to know if this method succeeded or failed.
Right, I agree.
You're not trying to
Yeah.
use the return value of a method to do anything but exactly what is required by the business or by the design of the system. No bool returns to say success or failure. No return codes to say success or failure. No, nothing to say success or failure, basically. What I'm saying is action methods should be doing and returning nothing to tell you whether it succeeded or failed. Who's good with that? I insert a customer, let's say as an example, I don't need to get an ID back. I'm saying it's a void returning method. Who can live with that?
Well, let me ask a question about that. If it fails, what are you suggesting it should do?
Accept it.
Exception? Oh, okay.
Yes. Because exceptions don't return. If I call a method and this method threw an exception, it doesn't come back.
Yeah.
Right? So it's not
You're
returning.
saying you should throw an exception that it's an action, you're expecting something to happen, so basically you need the equivalent of an expectation failed exception.
Yeah.
And you need to catch that and say, hey,
Yes, so one of the parts of PWI is programming to exceptions. Meaning the short of it is I love exceptions. I happily throw exceptions. I have a whole lot of exceptions in my system and then custom exceptions. I'm totally cool with exceptions. I don't have an issue with them. But if you learn to love exceptions, then you can actually use the benefit of exceptions without kind of going into the quandary of not knowing whether the system is actually working or not, because you're trying so hard not to have exceptions that you actually don't know whether the system is working or not. Because you're always trying to kind of, protect yourself. And I'm saying, if I didn't get an exception, there's a very clear assumption I can make. That system worked. That call worked. Because my system will throw an exception if it didn't. So I'm not in any two minds about something happening, disappearing into ether and not knowing whether it worked or not. If you embrace exceptions, there's no two ways. Either through an exception or succeeding. There's only two options. That's programming to exception right now. We're doing method design. But they're all connected, as you can tell. It's not like they're so independent, right? So if you're good with these two, then let's look at an example. I don't know if you guys can see in the back here. Eli, can you see them?
Yeah, I'll bring binoculars next time I visit.
So I didn't know we were going to be in this room. Yeah. So basically what it is, there's a small method here. This first method says get customer, 42 is the customer ID. It's assigned to a customer object variable. And the next time it says send order confirmation email and sending out the customer that came back from that first call. No checks, right? There's no ifs, no else's, nothing. Just simply blindly just call the next method. Now, the question in some people's mind would be, well, then what if customer came back with a no? Then you're going to have a null exception in the next call, right? Is that correct?
Well, maybe.
Maybe. Well, let's say it's no. Let's say it's no. You could potentially have a null reference exception in the next call, somewhere down that chain. Is that correct? Yep. So what do you do in this situation? What are the typical? Who's a Java programmer? Or you used to be?
So would you say in this case that you should throw an exception? Because
I'm saying
if
that
you get a data back, that's a failed expectation.
yes. So my method, my get customer method will throw an exception. So I can just blindly start writing code. I don't have to check for
I
it.
can not have an exception.
Yeah. See, because it's saying get customer, it's not saying search for customer. Right? So the difference between the locate and the search is, well, locate is saying you know the customer 42 exists, so I mean, heck, if that's what you tell me, and if it doesn't exist, I'm just going to throw an exception. I don't care. They're saying, fine, no, search for a customer 42. That's a different scenario. Right? You don't know. You're hoping you could find it. It's like a Google search versus something else, right? So get customer 42 as the IDE implies you know that the customer 42 exists. And if it doesn't exist, I'm just going to throw an exception. The benefit of it is, if it does exist, you can just keep blindly going down the next line and keep executing code without having to check for nulls or anything missing. The system, I mean, if you can extrapolate that to a larger system, there are no conditional statements in the entire system for the most part. Because you don't have to check anything. You are here, you're in this second line. What is the guarantee you have if the execution reaches this line? In what I just said. Sorry?
You have a customer and he's 42.
Right. Exactly. But imagine a large system, let's say I've got an orchestration, there's 10 lines, 10 method calls, and I'm on the 10th method call. What is the assumption I can make if execution reaches that 10th line?
It's not null.
Everything up to this point was successful. I don't ever have to wonder if it was or not. It couldn't have possibly reached this point of execution, if everything before it was not successful. Which means if you can make such a strong assumption in the way you write code, because you're programming exceptions, you don't need to have conditional statements to check everything. You can just blindly just keep going with the assumption. You're writing code literally for the happy path. That's it.
Yeah,
You're writing
I
zero
really
code.
disagree. That doesn't sound good. So, and the reason I say that is that you're talking to a database, right? 1,000 things can go wrong between your Windows WPF app or your console app and a database. So
Sure.
let's say the database is like can't connect or whatever. So that whole method's going to blow up. You got no coverage. That doesn't sound like a very good practice.
That's an exception, though.
What?
That would be an exception.
Well, he's not catching exceptions. This is going to bring the app domain down the way it's
No. We're not saying anything about the UI. The UI can happily catch any exceptions it wants. The system is not catching any exceptions.
So I can see.
There's only one try catch in the entire call chain. One try catch in the entire call chain.
And that's at the UI.
At the UI. The UI can convert that exception message to be friendly or display in a specific place in the UI. Or
Okay, so
whatever it is.
what you're saying, this looks like a UI thing, this is a console app.
It's an example.
Well, it's just
So you should have used the, yeah.
Should I use a WPF app to make it clearer? This is a UI.
No.
Or should I use
This is a UI app right here, and you have to
Yes.
catch exceptions.
Yes. But again, this is an example.
So in your service layer, you can write code like this, but not in the UI.
Correct.
Okay, so we can swap that out.
I'll change this stuff. Okay. Before I send it on.
Well, I'm very exact. I mean,
Yeah, no, I
No,
agree.
because
I'm just like you, don't worry. I know exactly where you're going.
yeah, you don't want people here writing UI code that doesn't catch exceptions.
Yes.
That'd
So
be
if this was in your system besides the UI, right? The UI, of course, eventually maybe initiates the call. The UI needs to catch the exception. But nowhere in my system do I have a try catch. Nowhere. No try catches, period. Happening throw. I mean, there'll be like gazillion throws. That if I don't like something, I will just throw an exception. But there's nothing to catch.
I agree.
And if you catch nothing, then every piece of code you write is really writing code for the Harry Potter. You're never trying to catch it and do something else with it and whatever. If you're pretending you can handle an exception, you're going to be in deep trouble because you can't handle all exceptions. You don't know what to do.
But
So
there
the best is don't worry about it.
But there are occasions when you can handle an exception gracefully and do something in order to
Something
resolve
useful?
the issue.
Something
Correct.
useful?
But for instance, if I'm calling another service that doesn't return, I may wait a moment and retry that service if it's something that I know, okay, this may not,
Okay, go ahead.
I may not be able
I got
to
it.
depend on this
Right.
to come
So you
back to
did,
this.
you tried it 10 times. When are you going to give up eventually?
Oh, absolutely.
And then what are you going to do? After all that,
And then send it up the chain,
but then throw an exception, right?
but why subject the user to something that I can handle
I agree
myself?
with it. But the problem is when people talk about retries, they assume for whatever reason the next try is going to work. And they don't ever write code to handle, or they don't think in terms of writing exceptions or throwing it, or the exceptions being thrown. They're really trying to protect themselves from exceptions being thrown. But in the case of your example, at some point you're going to have to blow up and say, you know what, I'm done.
And I'm good with
tried
that.
now.
And I'm good with that.
Right. And so the problem is if you don't think in terms of exceptions,
Uh-huh.
and programming exceptions, you're always trying to protect your ass. I'm saying don't worry about that.
And
Exceptions are going to be thrown.
But I'm not saying protect your ass. I'm saying don't
You're
make
using
things
retry.
user,
You're
don't
saying
make
retry.
things painful for the user if you don't have to.
Of course, but retries I think is given in our world of cloud. You got to retry. But that's at the end of the day, even the retry is going to fail. So
You can't.
right.
Yeah.
So if it fails, you still have to account for the fact that you're going to throw an exception anyways. Which means I can still program the exceptions. If this method were to talk to a database, and the database, the retry logic fails or does a exponential backoff and finally fails on the 15th try, I guess my code is still fine. I'm still good, right? Nothing have to change. So which is what the point is. The point is that you're programming the exceptions, which means you don't have to worry about nonsense coming back from some method that's a null or something missing or
But in that case, you would have, or you said you only have one try catch, that'd be at the UI, but that's one example where you would have maybe more than one try catch, right? You want to retry.
Oh yeah, but that's the library for that. It's not in your code.
But sure.
Okay, so
I
question.
should write that library.
Yeah, I mean there's retry libraries in Azure.
probably, yeah.
So in your .NET apps, where do you do the logging at? Do you use interception, or do you have decorators for your, or do you let your UI do all that?
Now maybe I should have started the conversation with saying the IT industry has two diseases.
The what?
Two diseases.
The
Our
IT
field
industry
has two diseases.
We do?
Yeah, so-itis and logging-itis.
What was it?
So-itis.
I don't know what that means.
Stack Overflow-itis.
Yeah, I don't use Stack Overflow.
Right, but so some of us are safe from it. Most of us have got the disease, right? And the other is logging-itis.
Okay.
Do you log?
Yeah.
Yeah. So then you got the disease. I don't.
I don't have a, I have a good application that
So-
can defend itself from the government.
I only log a specific kind of exception in my system. That's it. I don't log anything else. So there are business exceptions and technical. Business
So you
meaning
don't log if your database goes down?
that's a technical. I log it.
Okay, so you log all your technical.
Technical
issues.
exception. Business exception I don't bother about. So anything that I threw of my own that is a business exception just flies out. I don't log it. So I threw it. I know it. I threw it for a reason. If it's a technical exception that I threw, I would log that. And anything else that's a .NET exception that I somehow missed will be considered technical, which means I made a mistake. I should never get a .NET exception, but if I did, then it's technical, and I'll see it in the log, and I'll fix it at some point.
So do you do your logging in, let's go back to my question, do you do it in your UI, or do you use interception, or do you use like decorators on your business objects so you can,
So if I'm building like a web service application, then in my controller, there will be that try catch at the point of entry?
you do it in the UI then?
Yes.
Okay.
As in, if it's a service, it'll be in the service, but if it's in the UI, my service will still be doing the logging. I won't expect the UI to be doing my services logging.
Aha, so you are catching exceptions in your services.
Yes, because I have to translate the C# exception into an HTTP sort of format, status code 400, 500.
So you do have try blocks in your business
I
layer.
have one try catch
At the root.
at the entry point. One try catch, that's it. And only because I'm building a service, I need to convert that C# exception into a HTTP, error. And there's a bunch of things I need to do, massage the response back to the caller, in a way that's HTTP friendly, if you will, not this, it's not an exception.
Correct, right, yeah.
So
you're
that's why I
specific.
catch it. If I weren't building a service, I wouldn't be catching it. Then the UI would be doing it. So if the UI is talking directly to my business system, like a thick client,
Yeah,
yeah, then the UI would handle it.
okay. It's hard to give a general statement applied to every scenario.
So
You're doing a
yeah,
good job.
so you'll notice from the way I talk, I'm sort of trying to make a point.
Yeah,
There are odd cases here and there, but if I give you a lever, you'll take the arm, right? I'm saying you don't have. I'm not giving you any leeway, so which means you've got to fix your. Yeah, because you rationalize your way into anything, right? If I say, well, yeah, you could know, okay, then everything becomes that one scenario, right?
Yeah, I agree.
I'm saying you don't have those options.
Yeah.
Start there, then you can always ask for, little leeway here and there. But the way you want to think about it is like you can't do these things, and then see what works and what doesn't work. Okay. Now, I won't belabor this point, but because some people don't quite understand it, these things are complicated. So when I say things like, I didn't hop on the point for this. Yeah. So basically, if this method says, so in this case, the method says is get customers with claims to return a customer. So we can't find 42. What's it going to do? Yeah. So it's not giving me something. It's giving me exactly what it says it's going to give me, or not give me anything at all. It does not return. Now, if you know functional programming, these people, by the way, I like functional programming. In fact, a lot of my features or the ideas here are, it turns out that they're functional. I actually didn't know such a thing existed, but it turns out that some of them are functional in nature. Somebody just this afternoon will say, it's functional object programming. But in functional programming language, they would have a class. They call it an option class. So this get customer will return an option, and the option is nothing but a DTO kind. It has two properties: a customer and an error message. And if the customer is null, then hopefully there's an error message telling you what happened. And the error message is null, hopefully there's a customer, the one you asked for. So basically, I'm saying that's not what I'm saying. Okay? So when I say a method should return only what it claims to return or not return at all, don't say, but the method claims to return an option. No, it should be returning claim to return the customer, not an option. This is a cop-out. This is just a way to hack around what I'm saying. So there's many ways to, I guess, beat what I'm saying by trying to be smart. I'm just saying this is very simple. Don't overthink it. So are we now scratching our heads a little bit, wondering like what the heck is this guy talking about? No? Everyone's cool with it?
Cool.
This is exactly how you program?
Not cool with the,
You're not cool with it?
well, with the version of control stuff, I'm still with that.
Version of control?
The, well, dependency injection specifically.
Oh, we can, yeah,
I know you still
I
like- I know
can
you
catch
still
you
like
at
the
work.
version
I can
control.
catch you at work. You can have a big power at work. Oh, any of these guys here who've gone through PWA can lay you flat on the ground.
When you say method, you're not talking about like the iDesign method. It's method design. That's it.
Yeah, designing a method. It's like,
Okay,
what should I
there's a
name it? What should
pattern-
arguments be?
There's a pattern called the method from iDesign.
Oh, no.
So,
Yeah, I know you're talking about.
Just making sure.
Yeah, the method. No, it's not that method. But I mean, it's actually very close. Okay, I mean, I think people are constantly questioning things. Right? I say something, you hear something, you read something in a blog, you see something in the stack or whatever it is. If you don't question it, you're not going to learn a thing. Right? And unless we question every single thing, which is what I tell people, question everything, including what I'm saying, question it. Because if you just take it at face value, you're learning nothing, right? Because that's how you learn, right? You're all, most of us parents, you can say, do this, you tell the child, and the child just does it. Yeah, that's at that stage, of course. But at some point, you would expect the child to question you, or maybe you don't. Shut up, stop asking me questions. But yeah, the normal form of learning, or normal progression of learning is then you start to push the boundaries. What can I get away with? And then you start the actual learning experience. Then you start to question things. Why is this? Why dependency injection? What are the other options? So my first question to you would be, what other options have you looked at? And before you say that, I'll give you a metaphor, which some people think is really weird. Eh? So I'm a heavyweight boxer. You want to come in the boxing ring with me?
No.
But what I mean by heavyweight, I have tested and tried everything.
I don't want to fight you.
Seriously. So if you want to come in the boxing ring with me, you very well be trained.
All right, I don't like dependency injection anymore.
Don't give up.
You can't answer the simplest question. What else have you tried? You can't fight with me because I've tried them all. And I've agreed my own thing. I said the cons, what I'm picking is not flawless. It's just the cons I'm willing to live with. So given the cons of dependency injection, what I choose to do
Which
is
there
actually.
are none. Just reminding you back to.
Well, so I'd say the same thing to you. What are the other options?
Factory.
Huh?
Factory.
No, factory is not an option.
Why not?
Well, there's.
We're talking about multiple dependencies, right?
Yeah.
Like if a class has multiple dependencies, like, and you want to. Well, we can talk at
There's
length
other
of,
options in
you
there,
can
wow.
call me later on for a dependency injection versus blah talk, which also plays into unit testing because they're kind of in many ways connected. I've got my own ideas about unit testing. I've got 4 videos on YouTube on unit testing if anyone's interested. It's a long topic, but I used to be a dependency injector until I started finding problems with it. Then I went on a hunt to look for other alternatives. But that wasn't working for me. And then I tried other things, and today I'm in a different place. And today I don't have any those cons that I'm not willing to live with. I don't have those. There are other cons which I'm okay with. It's just not as bad as what I thought it was just dependent. See, I've got you guys all wondering, and I'm telling you to question everything. There's a lot of common practices in our industry. Everyone agree? Lots of common practices. Anyone? Do you agree? I'm saying common practice is not common sense. So don't confuse the two things. Common practice just says it's a common practice. People just have been doing it. But because nobody's asking questions, they just keep doing it. And next thing you know, you think that's the truth. It's not. Question it. Don't assume because it's a common practice, it's the right way. This industry, how old is this industry? How many people's parents are software engineers?
How many people?
Yeah, look at that.
What was the question?
People's parents.
How many people's parents are software engineers? What?
Yeah, my dad was, yeah.
Really? Yeah, that's unusual. He probably was one of the first few people who programmed.
Yeah, he started in 1952, I think, programming for the railroad in 52.
Okay. That's unusual, but what I'm trying to get across is this industry is too young. Okay, for the most part, we're not even engineers, are we? Because there's software engineers, what engineer? Yes.
So how do you feel that this correlates with the idiomatic programming that you mentioned earlier? So
Well-
if someone strongly feels that I is a poor name for an iterator and thinks that it's not common sense, what do you suggest for that person?
Okay, so idiosyncrasies of a language are independent of programming intent, right? Idiosyncrasies are more like there's certain conventions in a language, like using I for the iterator, the counter for a for loop or whatever. You're saying do you not use I?
No, I do. Just
I'll change it up.
Easy example.
Sometimes it makes sense.
Again, as long as you're being the idiosyncrasies of the language are being adhered to,
Yeah.
I'm not asking you to program in JavaScript or Pascal if you're doing C#. So you got to follow that language's idiosyncrasies. But naming, when I say name everything, people start naming their I variable in a for loop, and that doesn't even make sense. Like that's just making the code too complicated in my head, So I have to introduce that one more slide, idiosyncrasy is important to the idiomatic to the language. Does that answer your question? Okay, so common practice is not common sense. keep that in mind. So there's a nice story, maybe some of you know the story. One of my managers gave me, he says,
What?
I don't know the whole story, I'm not
You give me
sort of
some.
American born, so I don't understand some of the nuances here.
That's fine.
This little girl's watching her mother roast a
Anybody else needs to get?
Lego ham. And this mother's trying to explain to the daughter that the Lego ham needs to be cut, like just about here to do it correctly. And then the girl said, but mom, why do you have to cut the leg over here? And then the mom starts to sing and says, you know, I don't know, I think it's about like it gives the right flavor or something, I'm not quite sure. Why don't you ask the grandma? Like, so the little girl goes to grandma and says, grandma, like, why do you have to cut the leg of lamb over here? And she comes up with 10 other kind of reasonings in her head as to why. But you know what? You probably go ask your great grandma. You know, maybe she knows. So the little girl goes to great grandma, so that's 3 years down. Asks the same question. Grandma says, why, honey? I didn't have a big enough pot. But that's it. And for generations, this thing has been cut to this point because people have this idea that it has some benefit or value to it. And that's what common practice is, right? And there's common practices like across all kinds of walks of life, not just in programming. Oh, don't validate formal arguments. Who agrees with this? Don't validate the formal arguments of a method call. So when you're in a method, don't validate all the arguments you got. The
I
method
strongly disagree with that.
strongly disagree with that.
I always validate all of my arguments.
Yes, great. Who else strongly disagrees or slightly disagrees with that? Nobody validates their arguments?
Dark clauses?
Sorry?
Dark clauses?
Dark clauses.
Yeah, I have dark class for everything.
Right. So I'm saying don't do that.
Okay, I won't be working for you.
My philosophy says buyer beware. Not my problem.
So is this how you approach it in all of your
Yes.
projects?
I've been doing this for probably like 10 years now.
Oh my God.
As in this, and it's never, he's groaning.
No, I've met people like you, and we had to clean up the mess. It's crazy.
Well, they're not, I don't know if you can equate, two people on one sentence, but
No, I mean when you don't validate, because your worst enemy is another developer, right? They're using your software, and they don't understand,
oh, okay.
right? And
I'll
so-
address that, I'll address that.
Yeah.
I'll address that. But just take it at what I'm saying now,
Okay.
right? If we all didn't validate our arguments to all of our methods, and if I called your method, and your method blew up in my face, whose fault is it? Yours or mine?
Yours.
Cool. Caveat emptor. Buy your feature, and if I messed around with your methods, it's my fault, not yours. And if you all play this game, then all the validations of arguments disappear from every single method. The code just got cleaned up, and they're all cool. So there is a bit of an idea of a discipline within the team. Right? I'm not saying that everyone's free for all, but all these things are disciplines that we have to employ within our teams to make sure that we're all, and it goes a bit deeper, because the next slide is, if you lock the front door, we lock the back door, we're safe in the house. What does that mean? If all data coming into my system, the front door, is locked, meaning you clean up everything that comes into the system or you throw it out if you don't like it. At the point of entry, every piece of data is either cleaned up, and even after cleaning up, if it's not good, out. Only clean data comes into the system, so the front door is locked. And back door, it could be like a service call you made, to a service that's not yours, you don't own it, don't trust it. I've had cases with my database, I couldn't trust data, my database couldn't be trusted. Unfortunately, but that was the case. So you lock the front door, you lock the back door, you're safe in the house. There's no boogeyman under the bed, behind the table, behind the curtain, in the closet. Everyone's safe in the house. And so it looks like this. My front door is here. So I lock it. I do my validations. I clean up my data. Only good data comes into my system. And the same with the back door. The service call, database, stuff like that. Any data that comes to my system is cleaned up before it enters, or thrown out. So if I can't clean it up and it's still valid for me after it's been cleaned up, cool. If it's not, it's out. Now, since my front door and my back door are locked, the entire system is safe. None of us, if we're all on the same team, none of us have to worry about any bad data because we didn't let it in the first place. And if I call your method and I have a problem with your method, it's not your fault. I need to clean it up. I call your method incorrectly. I send you a null or something else, and you didn't like it. It's not your fault. It's my fault. I need to clean up my act and make the call and be okay. And if we all did that, suddenly the entire system just got cleaned up. There are 0 errors because of bad data. There are no conditional checking just to clean up the data. And the code is not cluttered with anything that's not even required in the system. You're always programming to the happy path. There are no unhappy paths.
Okay, so you're saying your public API, the entry points to your public API, those all have guard clauses.
Yes.
And the ones, then once that class, the methods that are called, that calls other things, you don't put guard clauses in.
Correct. Yes. So the data is cleaned up. No bad data is allowed to enter the system from any fashion. So even if I have a config file, the config file is like a backdoor, and it's coming from from the back of the system. That there's a config provider that makes sure that anything that comes into the system from the config file is either clean and therefore coming in, or it's not clean and is thrown out. Nothing is allowed to come into the system that's not considered correct, valid.
So, I'm just gonna, I'll defend why I do what I do, because when I worked at Microsoft, I can't tell you the number of problems that we had with code that wasn't perfectly written the first time, or it's evolved, and we had to go back in and put guard clauses on everything.
Right.
Because in the middle of somewhere, you could get something called a null reference exception, right? Whereas if you caught it at the entry point, then your stack trace looks a whole lot better, especially in a constructor, right? Because if your constructor throws before the object's constructed, you don't even have the correct stack.
Yeah, so
trace.
all I'll say to that is you're treating the symptom, not the cause. I can understand why you do
Right,
it.
because we didn't have any choice.
Yes, I understand why you have to do it, but I'm just saying you also have to recognize you're treating the symptom, not the cause. I'm saying nip the bud at the cause. Don't even worry about symptoms. There will be no symptoms. Now, I can understand you can't do this all the time.
Yeah.
But if we strive to this, I mean seriously, if and I've done this, you start the cleaning out of the system from the inside and move your way out and finding the right over here. And you're still never treating the symptom, you're only treating the root cause. So it takes a little longer, a little more work. But when you clean it up, that system suddenly becomes a whole lot more maintainable than the other version of it. Because the moment the boogeyman is in the house, the front door is locked, the back door is locked, and we are stuck in the house with the boogeyman in the house. You have no place to run. Right? There's no safe place in the house. So the best thing to do is to get that boogeyman out and lock the doors, so that you're now safe in the house. It's just a little more work, but it actually pays off, big time.
So how do you have a payoff by removing guard clauses? Okay, which constructor
The
writes.
guard clauses are just going out to the front door or to the back door.
No, I'm talking about in the middle now. So you're in the middle, and you have guard clauses, and you're saying get rid of them. And I'm asking, it's an extra layer of protection against all kinds of problems, and you're saying now we don't need those. Well, what's the downside to having them? I don't understand why it's cleaner when you
Conditional
have.
statements and a bunch of other things that, the code for to check every step. And if you have to check it, then he has to check it, and he has to check it, with none of us trusting each other. That means now everyone's having to check all their code, all the arguments to their methods. Like, it's ridiculous. Why? When the data started to be incorrect somewhere, the origination of it was probably at the point of entry. They fixed the bug, and now
Yeah, you still haven't solved me, but I understand what you're saying.
who's convinced and who's not?
I'm totally not convinced.
Okay. Well, it was good.
It's really interesting.
Yeah, it is.
I'm not sure that I agree with only having one try catch all the way at the end of the line. But I see what you're saying. So definitely something to try.
Yeah. So that's really what I would tell you. Without before.
I don't take exception to what you're saying.
What is that?
I'm catching what you're dishing out.
Rather than reject it completely, I would say try it. Try it sincerely. You'll find. I mean, everyone that has rejected it. This is another idea or another sort of concept in humans, right? Somebody proposes a new idea. Step one, all humans. The typical reaction is you laugh it off and say, "I'm a stupid guy." After a few years, it becomes a remnant reaction. You hate this person. You hate this thing. You can't stand for it, right? react very violently, and then a few years later you accept it. That's the standard process of acceptance in humans. New ideas are initially rejected, and you kind of laugh about it. Then the ideas are rejected, except they're more violent about the rejection, and finally you succumb. So he's at the final stage.
No, I've just learned from 30 years of software development that to write defensive code. And that
Yeah,
code
so
is
you know,
not
the thing is I used to call programming with intent defensive programming.
Sorry?
I used to call it defensive programming. Programming with intent, when I first started 15 years ago, I was calling it defensive programming. Then I called it locking it down, a bunch of other names. And I realized that I'm not being defensive at all. It's almost like I'm being offensive. I'm saying I don't give a shit about what you want to do incorrectly with my system. I'm never going to tolerate it, period. Out. Don't tolerate any nonsense. It's just almost like the backwards of it. But I said, it works for me, maybe it not work for you, maybe what you're doing works for you. I'm not arguing that.
It depends on your team, I guess.
Oh yeah, no, there are, the dependency is of course on discipline, but our entire industry is based on discipline. We don't have the tools to ensure that everything we do is somehow compiler checked or, tooling checked, and it's flawless. So we of course have to depend on discipline, on best practices or conventions and whatever else. So I don't think programming with intent is any different. It's just the reliance on the discipline within the team is heavy. The reliance on good code reviews is heavy, except I haven't built analyzers and all that I could do now with Roslyn, to take care of some of these things. But the key thing is that this thing works. I mean, I've been doing this for many years in large enterprises, and it turns out the system that I built don't have performance issues and don't have bugs. I have in Geico, I have a track record 6 years, 7 systems, 0 bugs. 0 bugs. No performance issues. Everybody else is talking with performance issues, everybody else is talking with bugs galore. I don't have any. You can call it, besides all of this stuff, my team is just exceptional, possibly. But I've had 6 different teams. But they've all built a system like this. So it just, there are some benefits to it. Okay, now, there are some things in programming that we do all the time, and so the little devils here are bad.
Shiv?
Yes.
Yeah.
Oh, really? I'm just halfway through.
Continue at 7 months ago.
Yes. Or you can go watch the YouTube video. But basically, I have issues with null or empty and null or white space, right? Because programming with intent is saying, like, are you not sure? Like, is it null or is it empty? Or is it white space? Like, which one is it? Do you not know? Are you guessing? Are you hoping for the best? Or you don't want to take the time to figure out which one it is and then apply the actual test for that? I'm saying, you take the bloody time, and you figure out what it is, and it's either a null, or it's an empty, or it's got white space. It's not all of them, for the most part, and of course in my world, I'm going to rush it. Strings are either null, or actual value. There's no empty string. So if I cleaned up the data in my empty point, it became empty, because I took out all the spaces.
Well, in C#, they're addressing this.
Yeah, because with the non-nullable reference types.
Yeah, now we have non-nullable reference types.
Yeah, and it works perfectly with this.
Excited about it.
Yeah, so the idea that I have for, it sounds contrary, because I'm saying my data can either be null, my strings can either be null or a value, but no empty. You think, okay, that's going to be completely backward to the new feature in C#8 that is non-nullable reference types. We're saying reference types can't be nullable. Yes. That means I'm left with a valid string at all times. It's just that simple. I don't have to worry about a null. Cool, I'm happy with it. Those strings will only have a valid value. It can't be null. It will only have a valid value.
So do you allow nulls in your columns in your database?
For the most part, no.
Yeah, so that means, good, we're in agreement, so that means that. Yeah, now you can go home and sleep tonight.
I know, seriously.
Yeah, no, so.
I'm not going to have a beer to cool down.
So that's an empty, but that's an empty string though, isn't it? It comes back with, so it's not null, it just doesn't have a value. Isn't that an empty string?
No, it
You
remains a
said
null.
there are no
If it's a null in database, it becomes a null in C#.
Yeah, well, we agreed we don't allow nulls in our column. So now I'm back to where you just said that there's no empty strings, when in fact that would be an empty.
Sorry, hang on. I think I'm going to have a hard time. Yeah, they're not nullable, correct. My database columns are not nullable.
Good.
So if it's not nullable, well, how am I getting an empty string?
Well, because if it's not nullable, there won't, and nobody's put any data in it yet, it'll just come back as an empty string.
Oh, no, so at the time of entering, setting the value, if my data is empty, it'll be set to null before it goes to the database. So if it can't go in the null as a null in the database, I can't allow it.
So you allow nulls in your column?
No, I don't.
Well, no.
What I'm saying is an empty string is considered.
Why you convert it to a null? That's all.
Right, that's what you're confused
Why would
with.
you confuse it to? Why would,
One
before
second.
you send it over to the database, why are you converting it to a null?
Okay, here's the thing. Forget the database. If let's say first name of a customer is required, and you call my endpoint that says, create customer, right? And you send me an empty string, I just blow it out right out. I don't, it just goes nowhere in my system. The fact that it's come into my system is not an empty string, and it's not a null.
What do you mean by blow it up, just so I understand the law?
Exception, throw it out, throw it
You're doing an exception, oh, okay.
Yeah, you're talking about
So I can't think
Okay.
about.
Just
So by the time it goes to the database, it's a good value. I won't be sending it to the database unless it was a valid value. So therefore, the notion of having a null going into my database doesn't occur.
So you're validating your data at the front,
Yes, at the point
where
where
you send it and you can go.
All right, so address line 2, not required, but you have a field for it, how do you handle that?
It'll be a one-to-many table somewhere. If the record is there, there's an address line 2. If it's not there, there's no address line 2.
A one-to-many table, what? Well, I'm just talking about a customer record that has address line 1, address line 2. That is not nullable, but you're not gonna get a value for it.
Think about another option. I'm still sticking to what I'm saying. I don't allow nullables.
Okay, it's not null.
Yes, I don't allow nulls.
Great, we don't, so we're in agreement.
Cool.
We don't have to bring that up
So then
anymore.
think of another solution.
But the screen-
If address line 2 is optional,
Yeah,
think of a solution that's a RDBMS based solution that does not allow nulls.
All right,
I'll leave that to you for your.
it's just an empty string.
I'm gonna call time.
It's very simple. It's a separate table. If the record exists, there's an address line 2. If there's no record for that specific address, there's no address line 2. If there's an address line 2 record for it, there's an address line 2. I'm not saving a null or an empty column somewhere for address line 2. I just don't have it.
Less rows.
Sorry?
Just less rows.
Yeah. I think it's a common.
It's not a row, it's a field and a record.
No, it's a direct row in my table. I don't do it the way you're doing. I do it another way.
Oh, so you, okay, yeah.
That's relational.
I know what you're doing.
That's a relational model.
You don't really do that for address too, though, do you? Separate table for that?
Yeah. I mean, for all kinds of things. Why not?
Basically, it'll be a list of fields,
I don't
and you
have-
associate the field and its
Seems
data.
so excessive.
Yeah.
Just for it, just for it.
Either that, or you have a whole bunch of junk in your code trying to protect it. Databases are good at that. That's what they handle really well, right? Joins.
Yeah, but you don't want to over.
Engineer.
Yeah.
Wow.
But I hope the three of you come for beer afterwards.
Shiv already said he's gonna beat me up. He's a heavyweight.
He's saying,
Metaphorically.
say I'm a heavyweight.
That is metaphorically.
I have to go to work tomorrow.
All right, thanks, Shiv.
Thank you.